continue to 3.4 unit vectors. Okay, vector quantities, okay, also often expressed in terms of unit vectors. Right, what is unit vectors? It is actually a unit for vector where it is dimensionless, okay, vector having magnitude of exactly 1. So the symbol used to represent the unit vector is I, J and K, representing the unit vector pointing along X, Y and Z axis or direction respectively. So if let's say you give a statement of 1i, it means that that vector is pointing to the positive x along positive x for magnitude or length of arrow of 1 unit. Okay, that is the meaning of 1i. If you are talking about 10i, it means that that particular vector is pointing along x but with 10 times of the length for this particular 1 unit or 1i. Right, so goes the same for the J, representing the y-axis, the unit vector for y-axis. The K is unit vector for z-axis. Next one is the component for each of the vector, single vector. For a single vector, okay, the component of it can be drawn in terms of this way. Let's say you have a vector A, okay, drawn like this. This vector A has component of X and also component of Y. Okay, so we've learned in previous topic, this is the way we draw the component of X of the A and also the AY. So the component of the AX is here and the component of AY is here. Right, instead of putting it as AX only, it will be proper to put AX with the unit I. Okay, so why is this having a hat like this? This kind of hat, okay, we call it circumflex, or you can simply call it as hat. It's representing a unit vector. Okay, so the product of AXI and the AYJ, okay, will develop or contribute or produce the A here, the solid A here. Right, so how to write down this information? So the A can be written as, in terms of vector, is actually how many magnitude in terms of X times with the I with this hat plus or combination AY with along the unit of J, vector B. B also has its component BX within how many units along x-axis plus combination, okay, BY along Y. Okay, how many units along Y? Right, if let's say you are going to do combination of them, okay, vector addition using components. So you are going to add R is equivalent to A plus B. Alright, so means that in terms of vector technique, you are going to do AX, okay, I plus unit vector of I, AY unit vector of Y, which is J, plus, okay, BX, how many unit in terms of x-axis, or I plus BY, how many units in terms of J or Y axis. So the R here will be in terms of AX plus BX in terms of I, how many unit, plus AY plus BY in terms of G. Right. you can simplify this formula in terms of this is component of the R in terms of X. In terms of X, Rx, which is component, okay, the addition, the total up between AX and BX, okay, in terms of unit I, plus Ry in terms of unit J. Right. So, in conclusion, we can say that, okay, what does that mean by Rx? This is actually AX plus BX. What does that mean by Ry? This is actually AY plus BY. Next one, vector addition using component. So actually, what we have done previously in terms of table, if you still remember here, in terms of this table, actually indirectly what are we doing here is the same actually to this method, to this one. So the resultant is a R, okay, where the resultant is combination between A and B. So you have A and the component of the A here, okay, AX, right, and the component of the BX here, right. Let me redraw for you. Okay, AX, the component of it here, here is the AX, okay, and the component of BX is here. This is BX. So adding up AX and BX give you the RX. Right, and then for the AY, it's here. This is AY. You can shift it to this, right, and okay, and for the BY, it's here. This is BY. You can shift it here. So, adding up BY and AY will give you the RY. This is what does that mean by components. Okay, actually we are doing the same thing with the table that Madam teach you before. Okay, magnitude of a vector. Okay, when you want to calculate magnitude of your R just now, okay, modulus here symbolize the magnitude. You are going to use theorem Pythagoras, okay, Pythagoras Rx square plus Ry square, right, where within the Rx you have AX plus BX, right, square plus AY plus BY square. Alright, this is the magnitude of it, but it is not complete yet because we are dealing with vector. Like it or not, you have to come out as well finally with the angle. Tangent theta, okay, is equivalent to Ry over Rx, okay. So within Ry and Rx is AY plus BY over BAX plus BX. So if it is direction only, the angle up tangent of, okay, the whole bar of this lah. Right. What is the angle? The angle just now is this one. This is the angle of your resultant, the theta. Right? So your theta just now, okay, reference axis, say this y, this is x. So let's say your R is somewhere here. Okay, so your theta here. This is the direction of your R. That's the meaning of this. Okay, so next one will be vectors in 3 dimension. Instead only consider x and y, now we also going to consider the z-axis. Okay. For the z-axis, remember the unit vector is k. Right. So let's say you have A having ax, the magnitude, and the unit in terms of x, unit vector, plus ay, unit vector of j, plus az, unit vector of k. Okay, this is your A. And then given to you for the B is bx unit vector of I plus by unit vector of j plus bz unit vector of k. Right. So now what you're going to do, you are going to determine the R where in terms of vector A plus vector B. What does that mean? It means that, okay, ax plus bx in terms of unit vector I plus ay by unit vector j plus az bz unit vector of k. Right. So right, the magnitude of your resultant, the R, is square root of Rx plus Ry square plus Rz square. Which one is your Ry, Rx and Rz? This one. This is your Rx. This one is your Ry. This one is your Rz. Okay. So we've done up to magnitude. We haven't done up to the angle. So I give you few options. If let's say you want to figure out cos theta, okay, to the respect of x, then you're going to use Rx over R. For cos theta to the respect of y, going to be Ry over R. For cos theta to the respect of z, it's Rz over R. Okay. So example 3.3. Now example 3.4, the resultant displacement. A particle undergoes 3 consecutive displacements. First one, delta R, equivalent to 15I plus 30J plus 12K centimeter. Delta R2, 23I, negative 14J, negative 5K centimeter. And delta R3, negative 13I plus 15J centimeter. Find unit vector notation for the resultant displacement and the magnitude. To solve this one, first to have the idea of what's going on, we want to find the resultant of R, where it's actually combination of 1 plus R delta R2 plus delta R3, all of it vector. Okay, where we have, okay, for R1 it's 15, okay, the I information is 15 plus 23 minus 13, all of this in terms of I, okay, centimeter SI unit, the unit, okay. Then plus this is for J, 30 minus 14 plus 15. This is for J, centimeter unit. And K, which is we have 12 minus 5 plus 0, because the last vector, the R3, has no value for K, centimeter. So where you're going to have, okay, 25I plus 31J plus 7K. All of it in centimeter unit. To figure out the magnitude of your R there, okay, it's by using Pythagoras, okay. The delta R x square plus delta R y square plus delta R z square. Right. So what is the value? Square root of 25 squared plus 31 squared plus 7 squared, right, give you 40 centimeter. Right. 3.5, taking a hike. Right, a hiker begins a trip by first walking 25 kilometers southeast from her car. She stops and sets up her tent for the night. On the second day, she walks 40 kilometers in a direction of 60 degrees north of east. Okay, which point she discovers a forest ranger's tower. Okay, so it is display in terms of this. Okay, so this is the first trip, this is the second trip. Okay, the final point is the forest tower, forest ranger's tower. Okay, so instead of taking A to B, okay, we can have another option, which is R. Okay, so first one, determine the components of hiker's displacement for each day. Right, for each day means that we're going to resolve every single thing. Right, so in terms of AX, okay, in terms of for vector A, right, for vector A, AX equivalent to A, right, A what? Sin or cos? Which one? Here. Okay, your angle is here. So to have AX must be cos. Why is it cos? Because the resultant of your A is lying there. So this is your AX. This is your AY. Right. AX equivalent to A cos theta. Okay, cos 45. Is it positive or negative? AX. Okay, positive. It's pointing to the right. And then it gives you 25 kilometer. Okay, cos 45 equivalent to 17.7 km. Right. And for AY is equivalent to A sin of cos. Sin 45 degree equivalent to 25 kilometer. Sin 45. Is it positive or negative? It's negative. Why is it negative? Because it's pointing downward. So it has negative here. So your answer going to be negative 70.7 km. Okay, for B, the component of it lies on here. This is BX. and here is by. Then you have your angle here. This is your angle, the angle for B. Okay, so for BX is B cos 60. Right, which going to give you 40 cos 60 equivalent to 20 kilometer. For BY, okay, it's B sin 60 equivalent to 40 sin 60 equivalent to 34.6 kilometer. Alright. Okay, for part B, you need to determine the components of the hiker's resultant displacement R for the trip. Find an expression for R in terms of unit vectors. Okay, you have in terms of X, yeah? In terms of X, here is AX. And here is your BX. Isn't it? So, combination of these will give you RX. Okay. And you have here AY. And here is your BY. Right, so combination of this along this give you RY. So now RX is AX plus BX, which equivalent to our answer just now, 17.7 plus 20 kilometer, which give you 37.3 kilometers. For RY is AY, forgot, plus BY equivalent to negative 17.7 plus 34.6, which give you 17 kilometer. So in terms of unit vector, your resultant will be 37.3 I plus 17.0 J kilometer. That is how to answer this question. That's all for chapter 3. Thank you very much for watching, and please do ask question if you have any problem regarding this lecture. That's all. Assalamualaikum.